Welcome back. So this will be the case study, the following robotic arm. We see over here the servo motors, and I'm really curious if Rodin can output a good model for this. So I have the model loaded. I'm going to hit generate, and we're going to go within step by step to see exactly how that mesh segmentation will work for the following robotic arm. Now, I'm expecting this to output some good elements over here for the cables, but maybe not all of them, and exactly, let's say, the location where those will go over here. But I want to know if this generative AI will manage to output this servo motor. So we have those over here. We have over here the gripper. If it will be able to do that mesh segmentation, so we can further go and animate this robotic arm. Now we see that the model is now being prepared. So I don't want to speed up this video, and I want to go step by step and see exactly how further we can go with mesh segmentation in this case study. Usually we should obtain a preview of the mesh somewhere around here underneath generating. So in this case, it was even faster. So let's take a look over here at the output. So it did embed the symmetry a little bit too much. So we see over here that the simple gripper was transformed like this. So this is due to the fact that this was set to symmetric. I can go over here and I will say that this will be an asymmetric model. For the perspective in this case, I will set this to be front left. And I will remain with triangles for this case study, but I will go with something lower. Let's say maybe 300K faces. So I'm gonna hit redo, and I wanna see if the new output model will be a little bit better. I expect it to be able to recreate that gripper. So we see over here, initially it tried to embed that symmetry. So it took this and it kind of mirrored it over here. So it wasn't exactly what should have been. But we saw that overall the other components are quite well defined. Not sure over here if each element will be that well defined within separate parts. This is why I want to do this case study, because I think it's quite interesting to see. So we see over here that we have this metallic element, the one over here, they will be joined together. So those are quite well defined. We see over here for that board, that symmetry embedded. Okay, and this is a little bit better. Even though over here for the gripper, this will not work. So we see over here that the components are not properly joined together. So we see that they should be like this. But that's, let's say, a smaller detail over here. Also, we see that the gripper is not attached. So I'm going to hit redo in this case until we're going to see that the gripper will be attached to the robotic arm over here. We see that the cables are pretty well defined. So that's something that I was expecting to see that. We see over here that that board has been raised over here, so quite similar to this design. We have over here those switches, which are not really added over here. I can go ahead and I can try to increase the amount of triangles to see if more details will output better results. Just like within my previous video with the wooden pinecone hedgehog ornament, we saw over there that when I increase the amount of faces, it outputted better models. So let's see, initially I will leave it like this, and after that I will swap to 1 million faces, and we're gonna start subdividing into individual meshes using that one. We see over here that the gripper, it should be, let's say, well understood that they are over here on the same axis. Not sure exactly why it made the gripper floating. So that depth map over here is not that well defined. We should get the preview now. So let's see within the preview. Okay, so the same problem over there. So I will just go over here and I will increase the amount of triangles to the maximum of 1 million. And I will hit redo and see if that gripper will now also be more detailed, because we see that within this iteration it's a little bit better. We still don't have those two, let's say, the fingers of the robotic arm attached to that top part, so we cannot really simulate this as intended, because we see over here that those claws, so the one on the top, the one on the bottom, they need to be connected over here so that we can simulate this. Regarding the details of the servo motors, we're going to see that those will be fixed like this with 2 screws. We're going to have a total of 4 cutouts over here for each, and within our model those are lacking also. This one, I'm curious now if I increase the total amount of faces to 1 million from 300,000, if you're gonna also have those small details, and I expect to have some of those. So let's take a look over here. So this is the updated version. The model has a little bit better details, but we still see that it lacks some elements. So those screws that we just discussed previously are not over here. We see over here that this is also not perfectly symmetrical. Maybe it didn't, since it was set to asymmetric, it doesn't really fully understand the shape over here. But let's bang this into parts and see exactly how that will work, because this was the main purpose of this video. I'm really curious if it will manage to make each of those servo motors individually. We see that this now takes a little bit of time since I added the 1 million triangle meshes. We are still waiting for the preview, and after that we're going to do the first segmentation and we're going to go further. So I'm going to hit generate for the first layer over here. Overall, the mesh segmentation works quite fast considering the high poly count for this model, as we can see it. Over here underneath the gripper, it's kind of a total mess. It's also not really centered with the top section over here, and it shouldn't have those elements. We see over here that cable that will connect to the servo motor over here will also slightly be generated over here. And they will just go over here, not within a cutout. So the first mesh segmentation should now be on the way to be processed. We are also lacking those fine details like the switches over here. We saw over here that we should have 2 of those. Initially, within the previous generation that was set to 300,000, I know that one of those was slightly modeled over there, but now it's completely gone. So we have the first mesh segmentation, and let's see the components. So we have over here a servo motor with that flange, but those 2 flanges are connected. We see this and that one, those should be separated. So I'm going to go ahead, and for this part I will split it again. So I'm going to go ahead and split it and see if the generative AI will understand that those will be 2 brackets and they should be separated. I'm not expecting this to work very well, since this is quite a complex model, but I'm still impressed with the overall output of this. So a few months ago, I didn't really expect generative AI to advance so far. And now we see that we have tools for mesh segmentation that are quite interesting. So this should now be generated. I'm going to go ahead and maybe over here where we have that that board, I will segment again. As you can see, while this is being processed, we can go ahead, we can select, but we cannot input another segmentation. So this will be blocked. The same for refine. So if for a section you don't really like the details, you can go ahead and you can refine that. That's a really good option. And within this case study, I'm going to do that for the claw because I really think that it can output a better model over here. But initially, I'm going to segment the gripper over here and only after that refine it. Because I'm curious if within the further refinement, it will still maintain those original references. Keep in mind that for this, I only use a single image input. Rodin can enable multi-image. And if I will add multi-image of the same robotic arm, I'm pretty sure that it will output a far better model. So the tool will better understand over here the overall shape and the fact that this is not a symmetrical design as within this perspective, but overall the whole robotic arm is quite symmetrical, and that is something that will help the tool. Now we have the mesh segmentation for this middle component with the two brackets and the servo motor ready. So let's take a look at that. So yeah, we have this individually. We have those brackets, but it hasn't been really splitted as it should have been. So we have the top bracket and the bottom one. It should actually be this shape over here and the one on the bottom, but Rodin just split it like this. So this was considered to be a separated part, so we didn't really understand the fact that we have sheet metal components over here with that thickness. Again, this is not intended for engineering. It's mostly for 3D models for visualization. So let's go ahead and further separate this gripper over here and see if the individual claw will be generated. I think they will be. So I'm going to go ahead and initially, I could do a refine. That will just output a different model. Not sure if only with this reference it will manage to output a better model. So I'm just going to go and have this generated separately. So we see over here that component, the bracket. We don't really have those two individual grippers within the preview. The individual, let's say, fingers of the gripper, but I'm going to go ahead and subdivide that and see what will be the output. Maybe the complexity of the model is a little bit too much since this mesh segmentation feature was just released. Within a further video, I'm going to go for something a little bit simpler that will be easier for the tool to interpret. This should also be the bottom section, the top one, and I'm pretty sure that it will manage to output that because it sees that cutout line over here where those two components will be fixed together. So let's see the overall shape of the gripper. And after that, we can go ahead and we can output the texture. But in this case, before we're going to try to approach the texture part, it's important to have the geometry correct. And as you can see, in some cases, it's not that easy. We see over here this bracket, and it will be attached over here. And in this case, I'm really curious if it will make that mesh segmentation. So we see over here that we have a bracket, and within that bracket, we're going to have the servo motor that will control the gripper. This is quite easy for us to understand because we can see the servo motor, we can see the bracket, we know how this robotic arm works. But we see that Generative AI doesn't really understand that. So I have a feeling that yeah, the servo motor was actually cut in half. So we have this section that should have gone through that, was added over here, and the other remained over here. And this will be the gripper. I'm going to go ahead and try to separate this once again and see if it will output those individual claws. I'm not having high hopes, but considering the fact that I select this mesh and I said that I want a new mesh segmentation, it will maybe output that. It's a little bit trickier over here to see within the front and top, but let's generate and see if we're going to have those individual claws. Based on that preview, I'm not expecting it to be defined, but we can already see how many of those components are added over here. And they also have this nice animation that will do this exploded view. And after the exploded view, all the parts will have the rotation axis set to the origin of the part, and they will just float over here in the air. So this is a really nice feature that will show the complexity of some of the models. And like I said previously, this is not, let's say, ready for engineering. Rodin is mostly intended for 3D models, for games and VR, AR, mixed reality application and so on. Not really engineering, but we can also work, as we can see, with some complex mechanical assemblies over here. So this should finish, and we're going to take a look over here if that gripper has been segmented. And as I said previously, within a further video, I'm going to go ahead and I will take something much more simpler, maybe like a gear reducer or something that is more obvious. We're going to have the shafts, we're going to have the gears, we're going to have the casing, and I'm pretty sure that it will work a little bit better over there. It will understand that each individual gear. Yeah, and we have over here the segmentation. We only have one finger, so which is this one. This hasn't been that further segmented, as I can see it mainly, I think, two components, but I'm not sure. But when we are happy with the mesh, we can hit over here conform, and this will use those credits. Keep in mind that each mesh segmentation will cost. So depending on the complexity of the model, if you're going to go ahead and you're going to segment it multiple times, it will use additional credits. We see over here that I had 205 and I hit generate. This usually takes 0.5 credits per mesh, but since I did that mesh segmentation several times, each of those will also use additional credits. I'm just waiting over here to see exactly how many of those credits have been used. They have this pay by result system, which I really like for a generative AI tool, because otherwise we can just separate them. If you are not happy with the output, we can just cancel. They will not, the credits will not be spent if you are not happy with the result. So we see over here a total of 2.5 credits. So 0.5 for the initial mesh generation, and after that I did 4 mesh segmentations, and this is the output. We can now generate over here that material. I'm going to go ahead and I will go with the HD texture in this case. As you can see, we have the option for the HD and the free one. The HD one will cost additional 0.5 credit. So again, this is not the perfect geometry. If you want to work with this robot, we want to simulate it. It's far from what it should be. It's a lot better to go and design this within a CAD solution like SolidWorks or CATIA or Fusion. But this is a good starting point for something like this. And I'm pretty sure that within the following, let's say, maybe not months, but years, we're going to have some CAD solutions that will be capable to recreate this. So we're just going to add an image like this of a robotic arm, and there will be some CAD solutions that will see, okay, this one over here, we can make this from plastic, maybe 3D print. They will define the width over here for the parts, so the thickness. It will see that this will be metal parts, so those will be defined within sheet metal, so we can bend them. And this will be quite interesting, and I'm pretty sure that that will be the turning point for CAD design. So we have over here the textures. They are decent, as you can see. Rodin tried to add some labels over here onto those. So we have those labels for the servo motors. It's not really that the same because this still uses the same generative AI textures that are not accurate. But yeah, this is the model. And overall, I'm pretty happy with the output. Let me know in the comment section what is your opinion regarding this. Maybe with texture it doesn't look that good since some of the texture are not that well defined, but if you're gonna go over here with the PBR material, or if I will just go with the plastic components, they will look like this. Okay, so I hope you enjoyed this kind of content. I will add a similar video over here onto the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.